Right now I'm going to walk you through Mitzvah's book of parent functions, and we're going to see the functions um, one at a time, how to graph them, and some of the information that I gave one of my classes today in class. So the first function is the constant function. Right? So the constant function is the line um, y equals b, or actually it would be f of x equals b, where b is any real number. So let's write here, instead of y equals b, let's write f of x equals b. Now, that means it's a horizontal line, right? And it crosses through the y-axis, whatever b is. It would be some sort of straight line. It would be here if f of x equals 2, that's this line. Down here, f of x equals, that's a -3. Right, that's that function. So it's always a horizontal line. So the y, the output is b no matter what the input is. So if it's -1, if it's 0, if it's 1, if it's 3. So for this function, the x-intercept will never happen unless I'm graphing the line f of x equals 0, which is indeed the x-axis, actually. This is the line f of x equals 0, and it crosses the x-intercept everywhere. The y-intercept will be at x is 0, y will be b, whatever that b is, as long as b is a real number. So, continuous or discontinuous. This one is a continuous function because I never have to lift my pencil or pen up to draw this line. So once my pencil or pen is down, I can draw in either direction. I never have to pick up my pen to finish the graph. The next function to talk about is the identity function. And the identity function is f of x equals x. So that's the line y equals x. So, for instance, always pick negative and positive numbers when you're plotting a function. So when x is -2, f of -2 is also -2, right? X at -1 is also -1. X at -1/2, also -1/2. At 0, it's 0. At 1, the outcome is 1. So the graph looks like this. If this is my x-axis and this is my y-axis, this is a graph that is a straight line with slope 1 and intercept of 0. This graph is also continuous. It's also continuous. Continuous graphs also have a domain of all real numbers. That's not the only thing that continuous graphs have, but that's one of the key features of continuous graphs, is that the domain will always be all real numbers. The next graph we're going to talk about is the absolute value function, and the absolute value function is f of x equals the absolute value of x. F of x equals the absolute value of x. So for this one, we can actually write it as two different lines that come together. Because if x is a positive number, then, so if x is greater than or equal to 0, then f of x just equals x. But if x is less than 0, f of x will be opposite x, okay? So that's defined piecewise. It's a piecewise defined function. So for instance, let's make a table of values. We have f of x and x. So if x is -5, this is what I'm saying about the opposite. The absolute value of -5 is just 5. So it's the opposite of what I'm putting in, which is -5. The opposite of -5 is 5. -1 is 1. At 0, 0. At 1, now it goes back to just this relationship. Plug in 1, get out 1. Plug in 2, get out 2. So we have a graph that is a line with slope of 1 and a y-intercept of 0, this direction. And on the other side, it's a line with a slope of -1 coming in this direction. All right, and those should meet here. It shouldn't pass. There we go. All right. So that's the absolute value function. It looks like a V. The next function worth noting is the quadratic function. It's f of x equals x squared. It's just the simple, the basic, the parent function. And this graph, by the way, the last graph was continuous. The absolute value function is a continuous function. This one is also a continuous function. So making a table of values, x and f of x. So when I plug in, remember start with negatives. When I plug in a -2, I can plug in a -2. When I square the -2, I get a +4. So at -2, I'm up here at 4. When x is -1, I have 1. When x is -1/2, I have 1/4. So that's like a quarter of the way through. That's -1/2. And then at 0, I have 0. All right. And then at 1/2, I have 1/4. 1/2, 1/4 is about here. Then I have 1, 1, 2, 4. 3 would be way up at 9. So if this is 4, 5, 6, 7, 8, oh, it falls off my page even. So the curve looks like this. It gets steeper and steeper and steeper as my x get larger, my y's also get larger, much larger. Right? So the graph looks like this. Note that it's curved here. And the reason it's curved is if we zoom in just in this area, let's zoom in right here at this little square. When we zoom in, what we see, let's make these, let's say this is the y-axis, this is the x-axis. We have 1, 2, 3, 4, 5, 6. Let's make them sixths. So let's make this 1. Oh, sorry, these would be fifths then. So then 1/5, 2/5, 3/5, 4, 5/5. Yeah, I can't do math. So they are sixths. 1/6, 2, 3/6 is the same thing as 1/2. 4/6. 4/6 is also 2/3. 2/6 is obviously 1/3. So 1/6, 1/3, 1/2, 2/3, then 5/6, and then 1. All right. So what happens if we have 1/6 squared? So 1/6 is my x value. My y value, my f of x value, would be 1 over 36. It's a tiny number. 1/3, squaring that, would be 1/9. All right, still really small, but a little bit better. 1/2 is 1/4. So let's say that this is, let's just make this 1/4. Right? If this is 1/4, then 1/9 is, this would be 2/8, 1/8. So 1/9 is even smaller than 1/8, so it's even smaller than half the way here. So let's just put it here someplace. So 1/9 is like right here. 1 over 36 is really small, right? We have 0, we have small, small, and now we're increasing to 1/4. If I take 2/3 and square that, I have 4/9. All right, so that's not even a half yet, right? 4/9 is still quite a bit smaller than 1/2. 5/6 squared is 25 over 36. That is bigger than a half, obviously, but I'm growing really, really, really slow. And then after 1, things start to really expand and explode, okay? And then things just get bigger and bigger when I have a value bigger than 1. So at 1, it would be 1. So if this is 1/4, then this would be 2, 3, 4/4. So at 1, it would be all the way up here at 4/4. Nope, still right here. Is that 1? Yeah. 1 and 4/4. So it really grows so slow. All right, but it grows faster and faster over time. All right, so that's the quadratic function. The next function we need to talk about is the cubic function. So the cubic function is the function f of x equals x cubed. So x, the third power, the third degree. So what does this look like? Again, graph a table of values, x and f of x. And also you still need to pick negative values. So let's start with -2. When I plug -2 in, so -2 times itself 3 times, that's going to be a -8. -2 times itself 3 times is -8. So at -2 here we have, let's see, 6, 7, 8, so right here. All right, that's pretty far down. Let's try -1. At -1, -1 times itself 3 times is -1. So that's way up here. All right, look at that gap. All right, as x changed by 1, y changed by quite a lot. But here's where it starts to slow. At 0, 0 times itself 3 times is 0. That distance is much smaller than the gap between here and here. All right, 1 and 1, 2 and 8. So 1 and 1, 2, and I don't think I have enough space. 1, 2, 3, 4, 5, 6, 7, 8. Falls way off. My page is way up here. Right? So again, this is almost like a parabola, the shape we just saw in the last one, the quadratic formula. Okay? So it's like the quadratic, only it's way more steep, grows a lot faster. Okay? So that side, but then this also is negative down here, so we're going to go in this direction. Okay. All right, so this grows really, really fast, but it's slower right in here, just kind of like the quadratic was. Only